Petronas Charigali is embarking qualification for non-metallic pipeline application for offshore pipeline and riser. The intention of this qualification is to develop new approach to mitigate corrosion during pipeline operation, especially caused by microbiological induced corrosion (MIC). At current stage, the project has reached technology readiness level TRL3, in which to proceed with large-scale offshore tests to achieve TRL4 and 5. Shanghai EB, as a specialized pipeline consultant through OPR Engineering, is entrusted to perform the offshore large-scale offshore testing. The tests including pipeline installation by towing method, on-bottom stability testing and riser configuration testing. The test is conducted approximately 8 kilometers outside Shida Port, Weihai, Shandong Province, China. The location is considered open sea, therefore it is expected able to stimulate real offshore environment, but still close to port for easy logistic and emergency purpose. For this installation testing, SHEB utilizes accommodation workboat AWB, assisted by 2 towing tugs and 1 anchor handling tug and supply AHTS vessel. All equipments, including holeback winch, launching assembly, launching chute, pipe reels and reel bases, hydrotest equipment, USBL, wave meter, monitoring system, current meter, tension meter, beacon, crawler crane, buoys and chain is arranged on the AWB. This methodology was intended to stimulate hybrid towing methodology, whereby the pipe will be launched near the intended installation location to minimize the towing duration. For this test, there are 4 types of pipes to be installed: Aerosun 6 inches RTP pipe, Aerosun 12 inches RTP pipe, Airborne 6 inches PE pipe, Airborne 6 inches PA pipe. Upon completion of vessel anchoring setup at the test site, the test is started with pipe assembly. The pipe reel first transferred to the reel base and secured. During offshore works, every activity is critical. Pre-job briefing is conducted to ensure every personnel must understand their job, schedule to complete each activity, and interface with other team who do concurrent or subsequent activity. For this test, reel transfer is very critical as it is considered as heavy lifting. The pipe is unreeled along the launching track specifically designed for NMP configuration. The chain is then aligned and strapped to the pipe. At certain distance, buoyancy tank to be installed to the pipe string. For this testing, SHEB designed special buoyancy tank that has slot for recovery line. The end of the pipe is then hooked up to the towing line, while the other end of the chain is hooked up to the holeback winch. The holeback winch will be functioning as tensioner to control the pipe string payout. Upon completion of the section assembly, the pipe launching begins. The tow tug comes along the AWB, passing the towing wire, which will be hooked up to the pipe pulling head. While the holeback winch controlling the tension, the tow tug pulls the pipe through the launching chute. During towing activity, the weather is not normally calm. Sometimes harsh weather also, such as strong wind, wave, haze. Big wave can cause the vessel rolling and affect the testing activity. Haze at night limits the visibility, which is very dangerous for vessel movement. Fortunately, the installation spread is equipped with vessel positioning system, which allows the captain and OCS monitor the movement of each vessel. But harsh challenges are able to be overcome using creative solutions such as utilizing the tug winch and modification of the pipe strapping methodology. Upon complete towing, the pipe is laid down. The buoys are stripped off. The pipeline stabilized on seabed for further on-bottom stability tests. The other tug will be repositioning herself to the AWB, ready for transferring the riser. The crawler crane then picks up the riser end of the pipeline string. The end of the riser is then secured onto the hang-off structure. The buoys are recovered back on deck. The on-bottom stability monitoring and riser monitoring are performed using ROV. The ROV is controlled from one of the tugs. Concurrently, pipeline hydrotest activity is also performed. To ensure no leaking during hydrotest, all piping connection systems are using high-rating tubing and fitting, and all connections are thoroughly checked and tightened. The pipeline pressure during hydrotest is continuously monitored and recorded using real-time data acquisition system. The hydrotests are recorded for 4 hours holding pressure. Upon successful completion of hydrotest, the pipe is then recovered back on vessel deck. The condition of the pipe is inspected visually for any sign of damage and any other failure mechanism such as dent or even buckle. All findings are recorded as part of the lesson learned to improve further the installation methodology and software. Upon completion of the recovery, next pipe are prepared and ready for launching. The procedure is repeating until all 4 pipes are completely tested.